Okay, hello students. Today we will be discussing out this fourth experiment for your strength of materials. That is, name of the experiment is to study out the stress and deflection analysis of column using ANSYS workbench. Okay, so for which we will be considering out a problem. Consider a column which is having a span of 6 meter. That is, the entire height of this particular column is 6 meter, and a point load of 10 kilonewtons applied at the top of the column. Okay, and the cross section for this column, it is a rectangular column, which is having a width of 0.45 meter and height of 0.30 meter, and for which we are going to calculate out the total deformation that will be induced out in this column. Okay, so we'll start out with the new project in ANSYS workbench. So I'll just click on ANSYS workbench, in which I'll be simply dropping out this static structural into this green box for starting out this column analysis project. So I'll name out this column project, which is having a span of 6 meter. Okay, I'll just enter out this and I'll just save out this project. It takes some time for saving out this project. So on a drive, that is on D drive, I have just created one folder. Sorry, on E drive, in ANSYS experiments. This will be my column project. Save. Okay. So by default, we'll be going ahead with the structural steel as the default material taken out by this ANSYS workbench. Once we do out that, we'll be going ahead with the geometry part. So I'll be right clicking on the geometry part and I'll be clicking on new design modeler geometry. So once I just click on new design modeler geometry, it will just open out this geometry window where I'll be drawing out the line for preparing out this column. Takes out some time. Once it opens out, we will be starting out with the sketching option and dimensioning out this column. Yes, it is now ready to draw out this sketch. So I'll just first of all click on XY plane, and in this blank area I'll be just right clicking and I'll be setting out the view in front direction. Okay, so I will start out with the sketching option and I will just choose out the line option here. I'll be drawing out this column vertically. Once I complete out this column, I have to dimension out this column. Just for a minute. And by clicking on the general option, I'll be just dimensioning out this column. Okay, now the current by default dimension, it is 18.595 meter, but my entire span for this column, it is 6 meter. So I'll just center out 6. Okay, which will just create out the height for this column. Once I just create out the height, the next command is to click on the concept option at the top, where I'll be drawing out the lines from sketches. So I'll be clicking on lines from sketches option here, and I'll be selecting out that vertical line of 6 meter that I have drawn out. Once I just click select out that, I'll be just applying out this option, and I'll be going ahead with the add frozen option for having the connectivity between these 2 points of this vertical line. Once I do out that, I will just click on generate option at the top. Okay, so once I finish out with the generate option, I'll be defining out the cross section for this column. So I'll be again clicking on the concept option here, and I'll be selecting out the cross section here. It is rectangular, for which I know the dimension, the width it is 0.45 meter and the height it is 0.30 meter. Yes, now the rectangle has been created out. Now the next part, the very important part for this entire vertical column, we have to assign out the cross section. So I'll be clicking on plus icon for one part and one body, where I'll be clicking on the line body option Once I do out that, I'll be selecting out the cross section which is to be assigned for this vertical column over the span of 6 meter, where I'll be selecting out the cross section as rectangular, okay, which will complete out the part that is related to the geometry. Okay, so once I do out that, I'll just move ahead with the third part, that is mechanical window. So I'll simply right click on this model option and I'll click on edit option, which will open out my mechanical window for doing out the further part, that is applying out the boundary conditions and applying out the point load which is acting at the top, okay, of the column, and whose value it is 10 kilonewton is the load that we are going to apply. We will apply at the top of the column. My mechanical window is just opening out. The column problem is very much simple to your horizontal cantilever. Okay, yes, we are just drawing out the line in vertical direction. In the case of cantilever, we were drawing out the line horizontally. Okay. So it takes some time for just opening out this mechanical window. This vertical line will be loaded out first of all in this mechanical window. Then we can further go ahead with the boundary conditions and application of the load for this column experiment. Takes some time. Yes, now the attachment is completed out. The vertical line will be highlighted in this blue background. Yes, you can just check out. Okay, you can also check out in this simply by clicking on the cross section. You can just have the idea regarding the column, how it will look out in 3D. Okay, so for applying out the boundary conditions and the force, I will be right clicking on the static structural command here. First of all, I will just close out these two windows. So I'll be right clicking on the static structural command and I'll be entering out the fix support first of all. Okay, I have to fix out the bottom part. Okay, so I'll be just clicking on the vertex option for selecting out the bottom node and I'll be applying out the fixity at the bottom. This blue icon indicates out that the column will be fixed at the bottom. Okay, so I'll be again clicking on the outline option and again I'll be right clicking on the static structural command here for insertion of the force which is acting at the top. So after right clicking on the static structural command, I will be inserting out the force. Okay, so for that force I'll be choosing out the top point where we are applying out a force of 10 kilonewton. Okay, so once I select out that particular point, I will just click on apply, which will just, this red color will indicate out the force is ready to be applied on that particular column. Okay, once I do out that, I'll simply just switch to view and I'll just set out this column in front view. Okay, so for defining out the force, okay, and just check out the XY axis. So we have to apply out the force in downward Y direction, that will be negative value. Okay, so I'll just choose out the components from which. So I'll be entering out the Y component which is acting out in downward Y direction, which will be negative value, which is required to be entered out in Newton. So 10 kilonewton becomes out minus 10,000 Newton. Okay, you can just check out the force has been applied at the top. So you can just simply check out with the boundary condition at the bottom. The column has been fixed out, and at the top we are applying a force of 10 kilonewton at the top. Okay. So once I just do complete out with the boundary condition, I'll be right clicking on the solution option here and I'll be inserting out the total deformation option first of all, and I'll be also inserting out the beam tool here to check out the stresses that will be induced out in this column, okay, or in this beam. Okay, once I do out that, I'll be just simply right clicking on the solution here and I'll be just clicking on the solve option. Once I just click on the solve option, it will start first of all with the mesh, then it will build up the mathematical modeling part, It takes out some few minutes for solving out this problem. Once we complete out that, we can just easily find out the results such as total deformations, and we can also check out the different stresses that will be induced out in this column. Okay, the total span of this column, it is 6 meter, and which carries out a point load of 10 kilonewton at the top. It takes some time. We are in the stage of post processing. Now the meshing part is 5%. Let it complete. Let it do out with 100%. It is taking bit of time. Yes, now the meshing is done out 100%. It will do out the mathematical modeling or mathematical calculation part. Again, it takes some time for completing out the 100% bar. We check out at the bottom, the green color shows out the progress for meshing and for building out the mathematical model for this column experiment. That is your fourth experiment. Stress analysis and deformation of column using out ANSYS workbench. It is building out the mathematical model. Once it completes out 100%, we will be getting out the different results which are related with this column problem. It is taking out some time. Currently 10% is the progress. Once it completes out 100%, we'll be getting out the results such as total deformation, and by clicking on the beam tool option, we'll be defining out the different types of stresses that will be induced out in this column. The problem is very much similar to your cantilever beam that is fixed at one end and which carries out a point load at the free end. Okay, only we are arranging out this beam or the column in vertical approach. Okay, so the step-by-step procedure that we have followed out for drawing out this column, first of all, we do out in the geometry part. We completed with the line. Okay, then we applied out the boundary conditions where we fixed out one support and where we applied out the point load at the top for solving out this column problem. It is 85%. Once it completes out the 100% part, we'll be getting out the results. It is 80% and it is ready now. So on that basis, we'll be getting out the results. So first of all, we will be checking out the total deformation that has been induced out in this column. Simply, once we click on the total deformation, you can just check out the total deformation in mm that we are getting out for this column. It is 0.0022222 mm. Okay, which is at the top, and at the fixed support the deformation is 0. Okay, so at the top we are getting out a total deformation as 0.0022 mm. Okay, so this is the total deformation, and you simply, once you click on the beam tool option, you can just check out the direct stress which will be in MPa. Okay, minimum and maximum combined stresses you will be getting out for this column problem. Okay, just for a minute. Again, we'll be again adding out some results, some more results for this column type of problem. You can also add out the SFD BMD for this column. Okay, and also check out the deformation in y direction also. Okay, so this was the problem for experiment number 4. That is, we have considered out here a column of 6 meter span and which carries out a point load at the top of 10 kilonewton, and the cross section is width of 0.45 meter and height of 0.30 meter, for which we are getting out the total deformation as 0.00222 mm. That is the total deformation that will be induced out in this column. Okay, so this was the fourth experiment in ANSYS workbench.